Okay, everybody. So what we're going to be doing today is part 2 of section 3.2. So last time in the last video, what we did was we did domain and range of a function from a graph or an equation. And in this one, what we're going to be doing is learning how to do some stuff with piecewise defined functions. So we'll go ahead and scroll past all the stuff that we did previously and get to piecewise defined functions. So what is a piecewise defined function? So a piecewise defined function is a function that's defined in pieces, as you can see here. So take a look at this function here, f of x. You see that f of x has two different formulas, x plus 2 and 3x minus 2. So when you see this kind of notation, what they're saying is f of x is x plus 2 if x is less than 3, and f of x is equal to the other function, 3x minus 2, if x is greater than or equal to 3. So there's actually two different formulas of f of x, and the way you decide which one to use is by what x value you have. An x value less than 3 gets the first function, and an x value greater than 3, well, greater than or equal, gets the second function. So any kind of function that's defined in a manner like this is called a piecewise defined function. Okay, so the first thing you need to be able to do is just to be able to use the formulas to evaluate functions. So we're just going to go ahead and try that with this function here. So also notice that here I wrote if, if, but here there's no if. Sometimes they do write if here. It's just that sometimes they do and sometimes they don't. And so I wrote it without because it's harder to understand this way, but you still need to. Anyway, so let's go ahead and try to use this function here. So this is the same function we just looked at. So the first formula is x plus 2. The second one is 3x minus 2. And there's two different ranges of x that we use them for. So what you would do if you're going to evaluate some function values like f of 1, f of 2, f of 3, f of 4, is you need to decide where the x value is, right? So here this is x equals 1, which is less than 3. Right? So if 1 is less than 3, then we should be using the first function. So use f of x equals x plus 2. Does that make sense? So what you're going to have is f of 1 is x plus 2, but you're going to plug in the 1. So we're using this formula, but we're putting a 1 in for x. So 1 plus 2, which is 3. Okay. So for the next one, we have x equals 2, which is still less than 3. So we're still going to be using that first formula, x plus 2. So use x plus 2 again. So we'll have 2 plus 2, which is 4. So there's the answer. Then we've got 3 and 4. Oops. So if we go ahead and we use the 3 here, now we have x equals 3. Well, 3 is not less than 3 anymore, right? So we only use this first formula when x is less than 3. When x is greater than or equal to 3, then you use the second formula. So x equals 3, which is greater than or equal to 3. So we'll use f of x equals 3x minus 2. So we're going to plug this x equals 3 into this formula. So it will be 3 times 3 minus 2, because we're just replacing the x with a 3. So 3 times 3 minus 2. And that is whatever it is. 9 minus 2 is 7. And then we have x equals 4, which is also greater than or equal to 3. So we are going to use that, we are still going to use that 3x minus 2. We're going to plug x equals 4 into 3x minus 2 and get 3 times 4 minus 2, which is 12 minus 2, which is 10. Okay, so that's how you go and you evaluate these, is you check which region you're in for your x, and then that tells you which one of these formulas you want to use. So every x value, you have to make that decision. Okay, so then what we want to do is we want to look at graphing. Okay, so this function here, we're going to graph it, but also, I mean, there is just a graph shown here. I'll show you how to get that on the computer in a minute, but let's go ahead and then just graph this by hand. So if you've got a piecewise defined function, like this one, 2 minus x, x minus 3, 2 minus x when x is less than 4, x minus 3 when x is greater than or equal to 4, then that's telling you you have two functions here. So one of them is f of x equals 2 minus x, but you only use that one for x less than 4, and then you have f of x equals x minus 3, which you only use when x is greater than or equal to 4, right? So if you're looking at a graph, so let's look at a blank graph here. Oops, it's a little bit crooked, let me fix it. So if you're looking at a graph like this, we go 1, 2, 3, 4, 5, 6, 7, and then, you know, maybe 1, 2, 3, 4. Probably far enough over that way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we have a blank graph. So let's not look at that graph that's already done. Let's look at the graph we have here. So what's going on here is you're going to need to graph both of these. You're going to need to graph f of x equals 2 minus x and f of x equals x minus 3. So let's start with this first one. So you can make a graph of this just using like a table of x and y values. Like maybe let's make a table of x and y values here. So like x, y, and we're gonna first plot the 2 minus x. So y equals 2 minus x. And we only want to do this when x is less than 4. So you can pick a couple of values. It's actually a good idea to pick 4. Even though it's less than 4, if you can plug 4 in here, it'll be good, because we actually need to graph this all the way up to x equals 4, even though that's where it switches over to the other function. So just pick a couple of x values here. So like maybe 0 and 4. That'll be okay x values. Let's plug those in here. So if you plug a 0 into y equals 2 minus x, you're going to get y equals 2 minus 0, right? Which is going to be 2. And if you plug x equals 4 in here, you're going to get 2 minus 4. 2 minus 4 is negative 2. So I get these values here, 0, comma 2, and 4, comma negative 2. So if I go to plot these, 0, comma 2 is right here. Oops. That's 0, comma 2. And then we've got 4, comma negative 2, which would be 1, 2, 3, 4, right here, right? And you can connect those. Actually, let me erase that real quick to show you something. If I can make it go through the points. Okay, there we go. So the line that I've drawn here, this line is the line 2 minus x. Oops. The line y equals 2 minus x. But that's not what we should have graphed, because we should only be graphing this line when x is less than 4. So this is where x equals 4 is, and x less than 4 is to the left. So instead of the line that we drew, which actually, let me erase that line that we drew. Oops, having trouble here with writing stuff. Let me, I don't know if this is a good idea. I'm gonna do it anyway. So let's like do this. Yeah, that'll work. So like what I've just highlighted is the line y equals 2 minus x, right? But we're only supposed to be plotting it when x is less than 4. So that's the left side of x equals 4. So what we should have plotted here is like this. This line, but only up to this point. And then here, actually, what we should have done, which you might have to do this in 2 pieces here. What we should have done is we should have finished this off with an empty circle. Now, why should it be an empty circle? Because this is less than 4, not less than equals. If it was less than or equals to 4, then you would fill in this dot. Okay. We leave an empty circle because we do not want to include the 4 here because it was less than 4 like this. Okay, and once you have that, that's the first piece of the graph graphed. Then you have to graph the other piece. So the other piece of the graph that we have is x minus 3 for x greater than or equal to 4. So you just make another little table of x and y values. X, y. This over a little bit. Y equals x minus 3. We use this for x values 4 and greater than 4. So maybe we'll use 4 and, well, the highest or the furthest I wrote on my graph here is x equals 7. So I'll go to x equals 7. And we'll plug those into this function, x minus 3. So if you plug x equals 4 into x minus 3, you get 4 minus 1, which is 1. Sorry, 4 minus 3, which is 1. And then for the other one, you plug in 7. 7 minus 3, which is 4. So we have 4 comma 1, 7 comma 4. So again, that's going to be 2 points on the graph here. 4 comma 1, which is like right here. And then 7 comma 4, which is like up here somewhere, right? And just like before, you can connect those like with a line, right? But we're not graphing that entire line. We only want to graph it from 4 to the right. So starting here, going that way. So let's get a color. And this is the way that we want it to go. And this one has a solid dot here. And it has a solid dot because of the greater than or equals, right? So if there's no equals, you put an open dot. If there's an equals, you put a solid dot. And so that's all we have to do. So we graph the first line and the second line, and this is what the graph looks like. And of course, if I make this smaller, you see that we just have the same graph that we did on a computer. Okay, now, if you want to make a graph like this, you can do that. Let's see here. We'll go to Desmos.com here to do some graphing calculator. And here you go. And what you do is you just type them in. You just have to type in both pieces and like this. So like if I go y equals 2 minus x, you get this line, right? The first line. But it doesn't end at 4, right? It's only supposed to be for x. less than or equal to 4. Sorry, less than 4. And the way you can do that here, which I can't zoom in, so hopefully you can see this, is you find curly braces somewhere. I just have this computer, so maybe figure it out. Ah, there we go. So curly braces, and then that's where you put x less than 4, like that. So those curly braces, it doesn't work. Don't, figured. So that's how you do 2 minus x for x less than 4. And then if you want the other piece, you can. The other piece was y equals x minus 3, like that. Of course, that's the whole line, and we only want the line for x greater than or equal to 4. So we'll have to go curly braces again, and x greater than or equal to 4, close the curly braces. And then that's how you get this plot that looks like this plot. The only thing is that you don't get the dots. So if you actually wanted dots there, you actually have to go and you have to type in the dots, like one of them's at 4 comma 1, right? 4 comma 1. You actually have to do that. And the other one is at 4 comma negative 2. So you can go 4 comma minus 2, like that. And you can change all the colors and stuff by clicking on the colors and stuff. So like I can make everything black. And then you can get the graph that is right here. So that's a little bit tedious if you're trying to get a graph that looks perfect like that, but you can do it, and you can see how to do the range with the curly braces for x less than 4, x greater than or equal to 4. All right, so that's how you do it. And so here's another one which we're going to graph by hand. Let's do that. So we've got 3 different pieces this time. We never said that there had to be 2, so there can be a lot. So we have for our pieces x less than or equal to 1, x between -1 and +3, and then x less than 3. And so I have like a chart here for x values. You can use those, but it'll be a little bit tricky. We'll try it. So let's start here. So x, when we start, x, oops, when we start, x is -6. -6 is less than -1. So we're starting here, right? So when we start, we've got, we'll be using 2x plus 5 for our y value. So we'll plug -6 in here. So you plug -6 in here. 2 times -6 is -12. -12 plus 5 is -7. So the first y value is -7. Then we have -2. Okay, -2 is still less than -1. So we're still using the same formula. So -2 in here. 2 times -2 is -4. -4 plus 5 is 1. So we have 1. Okay, let's do the third one, -1. -1 is still less than or equal to -1, so we're still using this first function. Plug -1 in here. 2 times -1 is -2. -2 plus 5 is +3. So we have some points. Okay, and that should be plenty to plot that first piece. So let's go ahead and put these on our graph. So our first point is -6, -7, which is here, right? The next one is -2, +1, which is right here. and then -1, 3, which is here. So we can easily connect the dots here, right? Like we could easily connect the dots for a straight line like this, right? But that's not the line that we should be plotting. We should only be plotting this for x less than or equal to -1, which x equals -1's right here. So this point should be where it ends. So we should only be plotting from here to the left, not this part. So this part right here, I should not have graphed. So let's erase that, and actually we can just probably don't need that. Go that way. Okay, so there's your first piece, which we plotted to the left of -1. Now from -1 to +3, we've got a new graph. So that's going to be, if you think about it, this first section of the graph here, x less than -1, is like this section of the graph, right? And then the middle section of the graph here, -1 to +3, well, +3 is here, right? So this section of the graph, and then the third piece of the graph is 3 or greater than 3. Sorry, actually just greater than 3, which is here this way. Right? So those are the sections of the graph. So we graphed the first one. We need to graph the second one now. So we need 2 points in here at least to graph. So it looks like we have 0. So right here, we're going to be using y equals 4. Right? When you see just a number by itself, that's just y equals 4. So x equals 0. You plug a 0 in here, but there's no x. So the answer is 4. Then 1. 1 is in between -1 and +3. So still the middle section. So you plug a 1. X equals 1 in here. There's no x, so it's still 4. Then you have x equals 3. 3 is still between -1 and +3. So it's still the second one. Plug a 3 in here. It's still 4. So actually, you just, from this whole section of the graph here, the middle section is just y equals 4, which is just a horizontal line at 4. So it's like this. Okay, now you have to get the endpoints right. So, oops. So this left endpoint has no equal sign. So the left side should have an open circle right there. The right side does have an equal sign, so it should have a closed circle at 3. So there's your y equals 4 middle section. And then your third section of the graph is for x greater than 3. You should be using this equation, 2x minus 2. Now I only put 1 point here. We're going to need at least one more. So let's put like 8 there or something. So down here, we're going to be using y equals 2x minus 2. So if you plug x equals 5 in here, you get 2 times 5, which is 10, minus 2, which is 8. And if you plug in 8 in here, you get 2 times 8, which is 16. 16 minus 2 is 14. Uh-oh, that's off the graph. So if you look at what I've got here, I'm in a little bit of trouble. Not really, but if you graph this point 5, 8, you can do that. 5 is here, 8 is up here, so you get this point here. But if you try to graph 8, 14, you know, that's like way up here somewhere. So that's hard to figure out. So we're going to need another point in here that we can figure out. So we're probably going to have to take like, oops, we're probably going to have to take something like x equals 4, or even x equals 3. This technically is not 4x equals 3, but we can still plug a 3 in here to see where it would be. And so let's actually do that. Let's put a 3 in there. So if you put a 3 in for x here you get 2 times 3, which is 6. 6 minus 2, which is 4. So 3 comma 4. Oh, which is actually 3 comma 4 is actually this point. So when you graph this section, technically there should be an empty circle at the end, but there won't be because actually this piece and this piece just end up connecting right here. All right, so that's what we get. So this is just 3 lines. So we had a straight line here in the first section, a horizontal line here in the second section, and another straight line here in the third section. And then just by happenstance, luck, when you plug a 3 in here, you get 4. And when you plug a 3 in here, you get 4. So they match up at 3. And there's actually no empty circle there. Okay. So that was a graph. And then let's do a word problem. So this word problem is copied directly from the homework. So, you know, if you can do this, then you should be fine. So all this is going to be doing is going to be having us write our own piecewise defined function based on what they said. So let's look what it says. It says the museum charges $4 per person. Let's write that down. $4 per person for a guided tour with a group of 1 to 10 people. So that's for 1 to 10 people. Okay. And then it says, or $44 for 11 or more. Or $44 for 11 or more people. Okay. And then it wants us to write that as a piecewise defined function. So first of all, the ranges here for the n values should be obvious, although you can't have like a half of a person, so that makes it a little tricky to figure out where the cutoffs are. But at least here it says $4 a person for 1 to 10 people, and n is the number of people. So 1 to 10. Now they've already put a 0 here, but we want 10 people to be $4 per person. So you might be tempted to put a 10 here, right? But the problem with putting a 10 there is it says it's $4 per person for 1 to 10 people. So 10 definitely needs to be included in this top group. And if you put a 10 there with a less than, that would be less than 10. So 9 people would be in the top group, and n equals 10 would be down here, the way it's written. So even though it's 1 to 10, you'll actually have to put an 11 here because it's less than 11. So 10 is less than 11. And if you do that, then this one, $44 for 11 or more people, well, that would just be greater than 11. Okay, so the cutoff point is 11. You put those in both places, and then we just need the formulas. So 11 or more people, the cost, which is C, the cost should be $44. So that's just a 44 down here. So that's the bottom function, 44. And then here, the top function is $4 per person, and the number of people is n. So that would be 4n, right? 4 times the number of people. And that's it. So $44 for 11 or more, 4 times the number of people for up to 11. It's actually less than 11, which would get you to 10. And that's it. We're just writing a function here. And that's pretty much it for the homework. You do have to be able to tell like which graph is which means you kind of need to be able to graph these a little bit. Don't forget that if you're having trouble with a graph, that you can go to Desmos and graph it. Just pay attention to how to graph piecewise defined functions. you don't have to worry about the points, endpoints, if you don't want to. And if you have a range for x here, like you can actually type in something like this, like you'd be able to type in like 2 less than x less than 6 or whatever. Um, 4, I guess. So like if you need it just um, a piece, you can see how to, or like if there's a middle piece, that's what I'm saying, right? Less than, greater than, or you can put x in the middle, like x between 4 and 8, using that curly braces as well. So anyway, that is piecewise defined functions, just the very basics of them. Good luck on the homework, and I will be back soon with another video.